Okay, so this is the lab for function templates, FT. So for function templates, I'm just gonna read off the thing. I'm not gonna show it. So for templates, it's like it's what Prasannas, it's what he said. Just a cookie cutter. So for each type name, we just gonna let the compiler figure out what type it is. And the compiler just going to try its best to create a function based on the type that is given. Okay. So for what type function? So it's super easy lah. Function template is just that. It's just a cookie cutter. Nothing much to explain. The difficult part is knowing what to do. Okay. So for now, here is just comments. This is just the declaration. I'm not gonna go through it. So for this one, let's start with alphabetical order. Or should I start with cases? That's one. Let's start in alphabetical order. Okay, for this one, let's start over here. For template, for copy, for what copy does, right? If we look over here. Okay, you know what? Just gonna go through based on this. So test swap. We are all very familiar with how to swap stuff already. So for test swap, we just take a temp. So since we are swapping common data types. Right? We're not like doing very complicated stuff. It's just int or car or student, right? We're just going to sort very easily. This student is a class that's initialized over here. So we don't really care about what it does. Just assume that they are correct. So it's just you just simply swap 5 with 8, and then so it's just very basic stuff. So what you just do, you just create. I don't need to explain this. So for test swap, this one's a bit more complicated. This one you swap over ranges. So when you swap over range, right, you now have range. You now have to do with iterators. So pointers. So what happens here when you swap S1 and S2? No, not here. And you swap ranges over here. This is an array. An array has a function, member function, dot data, which returns. Let me see if I can open up the C++. Okay, over here. Let me zoom in. So what it does, right, is that for array dot data, the way we call it is like this. You will just return a pointer to the first element, right? Pointer to the first element. So what we are doing with over here is we are doing with pointers. Okay. So for pointers, you just need to know what you're doing. So if you don't need like new templates, if you don't need like, you know that it is a pointer to something, but if you're just dealing with one type of data, like we're not dealing with pointers and then the pointer type. We're just dealing with pointers by itself. Wait, hang on. My cat is going crazy in the background. Never mind. So if you're just returning an array, not an array, you're just returning, you're just dealing with one type of data, right? You don't need to do like t star all the way, right? Because it doesn't matter. Even you put all the, if you want to put all here, you just put pointer, right? Compiler is going to see it as, it's still, if you, is still going to see it as like the same type of data. So it's just going to feed pointer data into this t1, and then it's going to be happy. It's not going to complain. So what I do here, right, is that I have a pointer data to 1 and pointer data to 2, so that I know which one is the first one, which one is the second one. In case the second one is a different type of pointers. Like let's say pointer to array, pointer to vector might be different, or pointer to array int, pointer to array car might be different, right? But in this case, it's not really tested, so just keep in mind. So for the swap, since it's a C star array, right, we are returning a point. Here's a pointer, so we can just do C star stuff. For this n, right, and what you guys need to know about n is, let's open up my useful whiteboard. Is it okay to say white? So what happens here if we have this array? Okay, dot. This is our begin. I think we are all aware of that. C star array, and then our n points not to our last element, but to the end of the array. So there shouldn't be an array here. So if you return this, right, you're gonna have a bad time. You're gonna have a seg fault. So we don't like seg fault. We like everything to be happy. So if begin not equals to n, meaning that if begin doesn't go to n, so if begin equals to n, means there's no more data, right? There's no more boxes, so there's no more data. So you get out of the while loop. Then while in the loop, you just call the O function and you just swap. Remember, you are dereferencing the pointer, and then for each time you swap, you plus. If you want to cut short on the time, you can just put plus here as well to make it cleaner. We can test this, and then WSL, test, nothing, no error. Oops, just didn't see that. WSL, then I run the diff, and there's no error. Okay, I'll pass you the make file also for this. Over here, sometimes you need to return swap, but for this one it's not, so there's no need to put this. So it's just, it can even be one line if you are really crazy. See? Oh, it looks like such a simple function if you do it like this. Okay, one line function. Okay, I'm having too much fun. Okay, so test swap range. Now remove. I'm sure a lot of people have trouble with remove and count. The rest should be quite trivial. But the problem that most of you have, right, is from what I experienced with one troubleshooting experience, right, the problem is not related to how you implement the remove function or the count function, but it's how you implement one other function that they all use, which is display. So for display, right, very crucial function. All these test functions all running display. So let's go to display. It's a D. So display. Alright, I'm just gonna hide it because it's spoilers. Hide it, yes. So for display, it sounds very simple, right? For display, what we are going to do, right, is we are going to put it in famous words. If you want to display an array, you just display. You just print the thing, then you display it. So you just print array, right? How to print the array? You look through. Remember, this is a C style, C style, right? Do it C style way. So just look through. Wow. Start not equals to n. No, don't put start. That doesn't make sense. First not equals to n, then just C out star first. Then since we got some formatting, we will put a space here. Put a space here, and then like that, and then this, right? So we will get this output, right? You will be able to get this. But if you do it for all of it, doesn't make sense, because what we will get a comma over here as well, won't we? Right? I mean, I can run the code so I can show it to you. I'm just going to run desktop. Does desktop deal with ranges? No, I'm just going to do swap ranges. Okay, let me just do the magic trick. Okay, and then in our HPP file, let's try to implement the whiteboard and blocking it so you guys can't see it. You guys can't see the correct method. I'm just gonna, so that you guys don't get spoiled. Spoilers, no spoilers. Okay, I wrote out exactly what I wrote on the whiteboard. I'm just gonna move it here. Okay, so instead of first I use begin, and then a lot of distracting stuff. We just hide it. Okay, so this is what we written so far. Our stc out first begin. So this one very important, so I'm just going to go through with everyone. What am I missing here? If I'm looping through something, right, there's one crucial fact that I'm forgetting. Maybe if I run it, then you guys will get an idea. So instead of make test, we will make debug. But you guys can't see it properly. Let me just reduce the size. Can you guys see that thing? No. Reduce it more. And then and then okay, I'm just gonna make debug. Oops, define but not use. Well, you know what, it's gonna be undefined if you're gonna complain this much. All these people. Oops, don't do namespace. What the fuck? Oh. What's this? Oh. Okay, that's enough. Can you guys spot the mistake? Anyone spot the mistake? It's running infinitely. and I know how they feel. So the mistake here is I didn't put plus plus. Whoops. Plus plus. So once I put plus plus, we shouldn't have the infinite loop. Yeah, no. Minus 1. Yeah, it was the first character here. Yep. Okay, so let me just comment out more swap ranges so it's much more easier to see. I don't need this, don't need this, don't need this, don't need this. Okay. Hang on. Okay, this is nicer to see. Okay. Yep. So you notice there's one mistake. The output file, right, does not look like this at all. There's supposed to be a new line. So it's not supposed to be one straight line. Like you can see, it's just one straight line, and even it's the next line. Like the next line got warp, right? If I do this, you can see it's actually one line. Wait, could you see it? Oops. Yeah, you can see it's actually one line. But now to make it proper. Okay. So what we are missing now is new line. So where are we going to put our new line? Are we going to put it here? Are we going to put it? Or are we going to put it outside? Correct answer is outside. So let's put it outside. Let's just use /n since it's the better one. And then let's run it. Yeah. Okay, we got the new lines. But there is still something missing. There's still something wrong. And what's wrong is our comma. I mean not comma. Our comma. Shit. Our comma. There's an extra comma here, right? That's not what we want. We only want it to be for these values. So what we can do, right? It seems that begin plus plus is over here. You notice that we increment the begin plus plus here, right? So let's work it out. Okay. So let's say last value is our n. Okay. This is our n won't have anything. Right. Let's draw it in line. Okay, and then this is our end pointer. So we plus plus, right? So let's say our first now is pointing here, and then we run the plus plus, and then it will point to n. Can we use this somehow to make sure that we don't print the extra comma at before the new line? Can we make sure we don't want this, because we definitely don't want this. We want it to be a clean new line. This is what we want. So what we can do, right, we can make use of this and this. Oh, nice circle. If we do this increment first plus plus and it goes into n, then we just don't print this, right? But it's a bit more complicated. So let's change the code just a tiny bit. So I'm sure this display issue might be a cause for a lot of people, because for some functions the begin is the end. There's no data inside, and if you run it wrongly, you will get a set fault. So make sure begin does not equals to end. Okay, then the second function we're going to run, the second guard we're going to run is that if begin. So this is a post incremented beginner. It's been incremented from the previous line. So it's ready. So let's assume that if we are at the last element, right, you increment here, it's going to be at n. So if begin, same thing as the top. If begin does not equals to n, then we just print comma. Then this will ensure that it will only print comma for stuff when begin is not equals to n. And see, we have no comma here, but we're missing the space. And yeah, that looks legit. Alright, so I can just push this back down. Okay, so display, very crucial function. Make sure that when you do it, right, because there was some guy, I'm not going to name him, but you should know who he is. If your begin does not equals to n, there are some functions where let's say like remove. There's a remove function later I'm going to cover. Let's say if you remove all values in the data, remove all values, right? So now your pointer is nothing. There's basically nothing. Your pointer is pointing to nothing, and then you try to print begin, the first letter, you're gonna get a set fault. So always make sure. I can't even spell. You're gonna get a set fault. Yes. Right. If your begin, if your end, shit. If your begin equals to n, and you try to see out begin, you will get a seg fault. Why seg fault? Because you remove all values already. Alright, so your n now points, your n always points to the element after the last, points to the memory after the last element. But if you have no last element, right, your n is pointing to the same, your begin pointer, right, they're pointing to the same thing, but there's nothing here. There's nothing here. Okay, it's now. So if you try to print now, it's not now, but it's pointing to nothing. It's a null pointer, so it's different. It's pointing to nothing. You are going to get a seg fault. Alright, so make sure your guard, pull up your guard, so that nothing bad happens. And I think most of you fix your display, you might fix the rest of your function if you try. Okay, let's go to our next one. Whoa, they all disappeared. Test remove. Okay, let's look at the output so we can understand what's going on. For test remove, what's going to happen, right, is that they're going to give you a value to remove, and you're going to remove it. So for this array, we're trying to remove -1, but there's no -1 inside, so you just return the same array, right? They're matching. See, if you highlight it, and then you can see that's they're both highlighted, so they're the same. But however, you want to remove -7, all the -7 in this array, and then you're going to return the new array without it, and then -1, you're going to remove everything, and your new list will be empty. If new list will be empty, you get a seg fault if you don't do it properly. Alright, very, very important, because you might think that, oh, maybe my remove is done wrongly, but no, your remove, if you just remove this test case, right, and the rest run properly, right, it does not mean that your remove is wrong. It could mean that a different function call might be causing the seg fault. Like once you remove your display, then this might be causing the seg fault. Alright, So for remove, what we are given, same thing, C star pointer, the start, the end of the range, and then the data that we don't want to remove. In this case it's an int, since it's an int array over here, I1, yeah. And then over here is a car array, and then yeah, there's no string array, so that's fine. And now where's R? R is here, remove. Okay, when T star temp, this is not a new array. This is a new pointer. You're not creating a new array. When you're creating a new array, means you are initializing it with values inside. You're not putting like values inside it. Alright? It's just a pointer. Okay? Let's get this straight. So this is a temp pointer that's going to replace the begin. So our temp pointer will become this. So it's not actually temp. It's going to be it's actually, think of it as result. Ooh. Think of it as result. So okay. So what we do as C star array, we're just going to keep doing this. Alright, simple stuff. And then if begin, so for our new array, right, we're just going to put the values that we want. If it's -7, right, we're not going to include him. We don't want -7, so we just don't include him in our new list. Okay, just auto-trace him. So this guard is going to make sure that -7 does not appear. If -7 appear, right, you're just going to ignore, and you're just going to ignore it and continue. If it's not, if it's any other number, it's going to store it into the new array. Okay, when you store a new array, you store first, then you increment, post increment. Then you don't put your begin plus plus here. You put it here, right, and you don't put it here. Oops. And you don't put it here, right? What's going to happen, right? Let me just do this. What's going to happen, right, is you're going to get a infinite loop. Because the logic is if and only if, then you begin plus plus. But if all the values are not what you want, you're just going to keep running forever, because your begin plus plus will not increment, your while loop will never end, and it's going to be a forever loop. So don't do that, bad habit. And you definitely do not want to put it here. When you put it here, right, you're going to store the next value instead of the current value. This one, by now, you can shit already. And then just return the result array. Okay, rest, short for result. What's the next one? There's remove for count. Count is another problematic one. So let's look at the output. I don't think you need this whiteboard already. Okay, for count, what we are doing here is that we're just counting the amount of times this value appear, and we are returning an int count. So you don't need to think so much about the return value. It's going to be int. And then for the things, I think this one, I don't really need to explain the logic so much, right? Okay, for this one, right, I'll explain more on the template. I don't explain the function. So for this template, we call a template T, and that, but we return an array. Then our parameters are array, and value of the array. Okay, right? Important. For count, it's the same thing. You can also do this. This is another different method, where this is an array, and this is the value inside the array. So array, and then value inside the array, and then your int count, because you're just going to count. It's just going to be int. doesn't matter, you can put size C or whatever. You know the value, you know the return, so it's okay. I don't have to explain how count works. And then find, yeah, okay, find, same thing. You can do as you can just do with one pointer. Okay, let's try out. You can just do it with one pointer. T, and then so T will be our data our data of the array. Then begin will be the start. N will be the start, and T will be the value. So we should be able to run find properly. If I make debug, I make test and there's no error. Oh, there is an error. Oh, what's the error? The error is here. That's not the way. Oh, that's all. Okay. And I change here, I need to change the header as well. Find. Let me find. Where to find? Okay. Conflicting type. Const in and int. Okay. Then I need to do this ambiguous because I didn't change it. Oh, still got some error. Maybe I can't do it. Okay, I won't do it now. Maybe you guys can find a way. Yeah, I won't do it now. I'm just trying to show you guys. It should be possible, but I don't want to waste your time to debug it. You guys try. It's a challenge. Okay, challenge for you guys. So you can do it this way, or you can do it in the swap way. Swap way, not swap way. In the remove way, where you need initialize one type name. Okay, and then what's next? Find. Copy. Function very simple. So copy. You might have two different array, so that's why there's IT2 and IT1. Okay, that's all. Fill. So for fill, copy, just copy. For fill, right, what you're going to do is that they're going to give you you just get an array. You're just going to fill it with this. Okay, fill it with 12, fill it with star, fill it with star, fill it with 12, fill it with asterisk and asterisk. So just fill. Same thing. They're all mostly the same. You can just do it in a single line. They're all single line function. Okay. So same thing. You can do it in this remove way, or can do it in a normal way. And then replace. What replace does is it just finds all the old value and replace it with the new value. You can't see it here because they don't print out the old value. You can see it here. So replacing P with P. Right. Oh, okay, now you can see it. So P is the original value. Then you replace it with the capital P. Don't know why it's repeated 3 times, but that's it. Then the function here, template, it is just like this. You can also do the star thing, but there's two parameters this time, one O and one U. I don't have to explain the function. Alright, minimum and maximum, and minimum and maximum, they are the same. You're just given two elements, two parameter, a pointer. Since you are just working with one data type, you don't need to say that, oh, this is a pointer. You don't do that. Alright, because you don't care about the value that's inside the pointer. You just care about this. So just do it like this, and then just increment. Use ternary. That's it. Okay. Oh, and something special is that what they expect is an array back, right? They don't just expect you don't just expect the raw value. They expect the array back. Yeah, you see, they expect an array. Max element equals to an array into an array into an array. Okay, so just give them what they want. And then for what's the next one? Equal, right? This one should be equal. Equal, nothing much to say. If they are equal, then just equal. Boolean, it's just true or false on here. If something is wrong, then just return false. Or if this guard never get triggered, then just return true. Then you might have two different type of array. So just play safe. But I don't think this test really tests for this lab really tests for that. And then for some, this one a bit complicated. For some, you need the T star. Okay? Yeah, basically like that. This is the start of the array, but you're not returning the array this time. Not like max element or min element. You are returning the data of the element inside. So that's why you're concerned with that. So that's why we will do this so that we can extract the inner data inside. And then make sure when you construct the data. Oh, they used the wrong one. Oh, was I explaining the wrong thing? Oh no. Yeah. So since you are explaining the correct one, you construct. You let the compiler decide what's the default constructor. If it's a string, it will be like this, right? If it's car, it will be like this. If it's an int or double, right, it will be like this. Let the compiler figure it out. Don't assume, right? So this is a value that's initialized to 0 in case there's no sum. Then let's do the C style loop. There's many different ways to do it. Then if res plus equals this one, you get res back. So let's say this one it's just like function overloading. If it's an int plus equals, they'll add up together. If it's a car plus equals, they will just become like that. They will just add up the string together. So it's supposed to be like this, but they just add up the string together. Great. Maybe we can look at the thing. Over here. So it's learning about C++ template. So it's returning the same thing. So nothing much. But here it's learning about C++. It's two different strings. So you concentrate it properly together. Right? And same thing over here. They're all different strings. Oops, I move on. Oh. But yeah. Then you just add up all together. and then it will print out properly. So this is mostly just a compiler. You just do everything, then you just tell a compiler to do its thing, okay? And then that's it. There's really nothing much to say about this except for commenting, and then make sure that you follow the instructions. Yeah, I forgot to add this, but you can do it. Okay, that's all.